Vectors. Vectors can be seen as from diagram or as column vectors. I'm going to begin with column vectors as these are what appear on both higher and foundation. Now a column vector is written like so. For example, we may have the column vector 2 minus 3. And we're going to show what this means from a diagram. From physics, you may recall that vectors have a magnitude and a direction. So vectors are directional. So for A, we have 2 and minus 3. So if we pick a starting point for our vector, the x direction is 2. Now it's a positive 2, which means we move 2 units to the right. Y is minus 3, so we move 1, 2, 3 down because it's a negative value for y. And where we end up, we join that together and we show an arrow because our vector is directional. If I wanted to represent 2a as our column vector, it's going to be double a, so 4 minus 6. To show what that would look like, we can pick the same starting position, or we could start somewhere else on the grid. And we go 4 units to the right and 6 units down. Join those points together, show your arrow for the direction and label as 2a. Now before we get into some exam style questions, I just want to recap some key understanding before we look at more difficult vectors questions. I'm going to start with a parallelogram A, B, C, D. It's very common to get parallelogram questions. Now just a reminder, parallelograms have 2 pairs of parallel lines. Now let's say the vector A to B, so we show that by an arrow showing that we're starting at A and we're going to B. And let's say that's represented by A. Now we don't need to refer to any column vectors when dealing with diagram vectors. We can just leave it in terms of our letter. Now because in a parallelogram opposite sides are equal and they are travelling in the same direction, that is to say D to C is also A. So in the same sense, if A to D is B, then B to C is B. What about if we were going in the opposite direction and we wanted to go D to A? Now we're changing direction, but it's still going to be the same magnitude. So now we're going in the negative direction. Same magnitude of B. If we wanted to prove that lines are parallel, let's just show by our lines. These are 2 parallel lines. They are travelling in the same direction. However, they're different lengths, so they will have a different magnitude. So for example, if our first line has vector A, our second line might be 3a. It could be any multiple, but the A, the directional quantity, will remain the same. So if our line was A plus B, a line parallel to that might be 2A plus 2B, because that is going to be twice as long as A plus B, but travelling in the same direction. Another style of question you may see is proving something is on a straight line. So let's take the straight line ABC. And let's say A to B is A, B to C is twice A to B, so 2A. And that's to say then that A to C is A plus 2A, which is 3A. So again, they will all have the same vector quantity as they're all travelling in the same direction, but they just may be different multiples of that. But what you'll notice is that they will sum. So A to B plus B to C will add to give us A to C. So let's put these basics into practice. So we're going to start with a column vector question. So this may be on a foundation or a higher paper. Here we have vector A, and on the grid draw and label vector minus 2A. So A, we're going in upwards, so we start here and we end here. We are going 1 unit to the right and we are going 2 units up. So A is 1, 2. We now want minus 2A. So we multiply by minus 2, giving us minus 2 minus 4. And we can start anywhere. We are going 1, 2 units left and 1, 2, 3, 4 units down. We're going in this direction, minus 2A. So A was 1, 2, and we want to add 2 lots of B. So B, we start here, we finish here. We are going 1 unit to the right, and we're going 1, 2, 3 units down, so minus 3. So we want A plus 2 lots of 1 minus 3. That's 1, 2 plus 2 times 1 is 2, and 2 times minus 3 is minus 6. And now we just add across. 1 plus 2 is 3, 2 plus minus 6 is minus 4. On to slightly more difficult vectors questions now. OAB is a triangle. O to A is A and O to B is B. Find AB in terms of A and B. So we want to get from A to B, but you notice we cannot go via this route because we don't know what any of the vectors along that line are. When this happens, imagine this road is closed, you take your diversion. So we're following that yellow highlighted arrow. So we are going backwards, we are going A to O, and then we're going from O to B. If O to A is A to O is minus A, plus O to B, which is B. And that's our final answer. Next, P is the point on AB such that A to P, P to B is in the ratio of 3 to 1. So this is 3 parts, this is 1 part. As a fraction, that would be 3/4, and that would be 1/4. So 3 out of the 4 parts are A to P, and 1 out of the 4 parts are P to B. Find O to P. So we are finding the vector that goes straight through here, but we do not know going straight through, so we follow an alternative route. Let's go this way. You could also go that way, and you will end up with the same answer. So to find O to P, we are going from O to A, and then we're going A to P. O to A is A. A to P is 3/4 of A to B, which we found in the first part of the question. Expand your brackets. So that's minus 3/4 of A and 3/4 of B. That's 1A minus 3/4 of A, so that equals 1/4 of A plus 3/4 of B. And that's in its simplest form. You could go further if you wanted. You could take out 1/4 as a common factor, and in the bracket would go a plus 3b. So either of those forms are correct. So this last one is a 5-mark question, which we would expect to see on the very final few questions of a higher paper. ACEF is a parallelogram. Remember, that's an important point when we have parallel lines. B is the midpoint of AC, so that is halfway. And M is the midpoint of BE, so we have a halfway point. C to B is A, E to D is B, and D to C is 2B. Show that AMD, so just a line that we cannot see right now, but we can jot that in here. Show that AMD is a straight line. So to do that, what we could find out is A to M, M to D, A to D. We don't need to find out all three, but we need to find out at least 2. Reason being is they will be a multiple of each other. So let's begin. What we know is our E to C, if that part's B and that's 2B, the whole line is 3B. So that's to say, because our line is parallel, this is also 3B. If C to B is A and B is the halfway point, that's to say that B to A is also A. So this whole line here is 2A. So E to F is 2A. So let's start by finding A to M. Now to find A to M, we need to go via an alternative route. So let's go A to F, F to E, E to M. A to F plus F to E plus E to M. A to F, so we're going in the opposite direction, so that's minus 3B. F to E, opposite direction, minus 2A. E to M. Now M is the midpoint, so that's to say E to M is going to be a half of E to B. E to B we don't know, so let's find that out. E to B, we can follow this green dotted line. 3B plus A. So now we know 3B plus A, we can pop that in here. And now we simplify for A to M. So minus 3B plus minus 2A plus 3 over 2B plus a half A. Collect your like terms. Minus 3B plus 3 over 2B. So I like to keep these as fractions, but you can do them as decimals if you want. So that gives us minus 3 over 2B. And then we've got minus 2A plus a half A. So minus 2 plus a half is plus, get the sign correct, minus 3 over 2A. What I'm going to do at this point is I'm just going to take out our 3 over 2. So A to M, we could take out minus 3 over 2, or we can just take out 3 over 2, because they both have that in common, so minus B minus A is what we're left with. So then we want to find either M to D or A. Let's find A to D. So we're going to go A to C, C to D. So A to C minus 2A, c to d plus 2b minus 2b, sorry, because we're going in the opposite direction. Take out a factor, which is 2, so that's minus b minus a. So here we see that our vector quantities are the same, minus b minus a minus b minus a, they are different multiples of each other. So we could finish the question there, or we could go further and find m to d, and hopefully that will simplify to give us r minus b minus a. So m to d, so we don't need to do this final step to get the 5 marks. The 5 marks has been done already, but we're just going to prove if you wanted to find m to d instead of a to d, how it would work. So m to d is the m to e, so e to m was 3 over 2b plus a half a, so we're going to change those signs because it's the opposite direction. And then we go e to d, so plus b. And then we simplify, so minus 3 over 2b plus b is minus a half b minus a half a. Take out your common factor, leaves you with, in the bracket, minus b minus a. So the vector quantities are the same for each, which proves they are on the same straight line. We can also see that 3 over 2 plus a half equals 2. So a to m plus m to d equals a to d. Therefore, they are on the straight line.